Hello guys, in this video we'll be learning about binary arithmetic coding. In our previous videos we saw floating point arithmetic coding. Now we'll see binary. So let's start. So this method is also called arithmetic coding with output bits. So this is similar to floating point arithmetic coding. In this we output some extra bits, okay, as the output. Next, this method is an extension of arithmetic coding. Some steps are similar to floating point arithmetic coding, and the output is a binary string of code words. So let's move ahead. So here I have the algorithm: arithmetic encoding, message, current interval equals 0, 1. This is your initial interval. Bit count equals to 0. Bit count is a counter. While the end of the message is not reached, read letter xi from the message. Divide current interval into subinterval, IR current interval. Current interval equals subinterval in IR current interval. Then this is one function, output bits, used for outputting the bits. And this is finish arithmetic encoding. This is the final step. Okay. So let's move ahead. So here I have the output bits function. So you can go through it. You can take a screenshot for your reference. I'll explain you this while solving the problem, okay? So this is your output bits function and this is your finish arithmetic encoding function. So this is your last step in the problem. We'll say this while solving the problem, okay? So let's move ahead. So here I have an example. Given the source s equals a, b, c hash and probabilities p equals 0.4, 0.3, 0.1 and 0.2. Encode the message a, b, b, c hash. Okay, so let's start. So these are the formulas used for making the subintervals. Okay, so this is for the first column and this is for the remaining column. R is previous is right of previous. Okay, we have seen this in our previous videos, so you can refer those videos. So let's start. Here I have the table. So first column is bit count, second current interval, input letter, output bit and subintervals. Okay, so make this table. Then what you have to do is take the first initial interval, that is 0, 1. So this is your initial interval. So now take the first input letter, that is A, and what you have to do, first step, you have to divide this subinterval. Divide this interval into subintervals. Okay. So how to divide this into subintervals, we have seen this in our previous videos. So you can refer those videos. Okay, so after this, after making subintervals, what we get is these 4 subintervals. Okay, so we have 0, 0.4, 0.4, 0.7, 0.7, 0.8 and 0.8, 1. Okay, so now what you have to do is check the input letter's position in the source. So what is the position of A in the source? So we have A at position 1. Okay, so this is position 1, 2, 3, 4. So we have A at position 4. Sorry, A at position 1. So what we do is, since A is at position 1, we take the first subinterval. Okay, so whatever the position, take that position's subinterval. Okay, so this is position 1, 2, 3, 4. So we take the first position, that is 0, 0.4 as our next current interval. Okay, so whenever you get a new interval, new current interval, then you have to follow this algorithm. Okay, so this is your output bits algorithm. I have simplified this for you. So you have to check the current interval with these 3 cases. Okay, so let's see where 0, 0.4 lies, in which interval. So as you can see, 0 is greater than equal to 0, and we have a 0.4 here which is less than 0.5. So when the left hand side of current interval is greater than equal to left hand side of this, and the right hand side of current interval is less than this one, less than or equal to this one, then it falls in that subinterval, okay, or range, okay. So 0.4 falls in this. So now what you have to do? Output 0 plus bit count number of ones. So output a 0 and bit count number of ones. What is bit count? 0. So we don't have to output any ones, okay. So only a 0. So now next, set bit count to 0. Bit count is already 0, so bit count remains 0. Now double lower and upper bound of current interval. So you have to double the upper and lower bounds of this current interval. So what do you get? Double of 0 is 0 and double of 0.4 is 0.8. So you have to multiply these two by 2, okay. So you get 0.8. So now you got your new current interval. So now you have to check this with the algorithm. So we have 0.8. So check if 0.8 falls in this or this. So 0.8 is greater than 0.5, so it doesn't fall in this. We have a 0 which is less than 0.5, so it doesn't fall in this, and we have a 0, so it doesn't fall in this also. So what we do? We stop here and take the next input letter, okay. So our next input letter is B, so we take that input letter. Next, whenever you take a new input letter, you have to make the subintervals of the current interval. So after making the subintervals of this, you get these values, okay. So now what you have to do, whenever you take the new input letter, check the position of input letter in the source. So position of B in source is 2. So what do we do? Choose the second subinterval as our next current interval, okay. So we have 0.32 and 0.56. Now check where this subinterval, current interval falls, okay. So 0.32, 0.56, let's see. So 0.32 is greater than 0, but we have 0.56 which is greater than 0.5. So it doesn't fall in this. So we have 0.32 which is less than 0.5, so it doesn't fall in this also. Now check here, we have 0.32 which is greater than 0.25 and 0.56 which is less than 0.75. So it falls in this one, okay. So now what you do? You have to output nothing. That is, you don't have to output anything. Next, bit count plus plus, you have to increment the bit count. So now your bit count becomes 1, okay. Next, you have to subtract 0.25 from lower and upper bound and double the lower and upper bound of Ci. So after subtracting 0.5 and doubling, what you get is these values, okay. So you have to subtract and double from both, okay. So after subtracting 0.25 you get 0.7, and after doubling you get 0.14, okay. Same for the right interval. So you get the new value, okay. So now check this value with the algorithm. So 0.14 and 0.62. So 0.14 and 0.62 doesn't fall in any of this, okay, if you check. So what do? You stop and take the next input letter, okay. So next input letter is B. So after taking the input letter, what do? Make the subintervals. So you get these values. Now check the position of B in source. So you have B at position 2. So you choose the second subinterval as your next current interval. Now check this subinterval or the current interval with the algorithm, okay. So if you see, we have 0.3 and 0.4 which falls in this one, okay. You have to go from left to right, okay. So it falls in this range. So now what you have to do? Output a 0 plus bit count number of ones. So output a 0. Now what is your bit count? you have a bit count as 1 here. So you output 1 1. Okay, one number of ones. So you get a 0 and bit count once, that is 1. Okay, so next what you do, set bit count to 0 and double lower and upper bound of Ci. So set bit count to 0, this bit count becomes 0 and you have to double these two values. So after doubling you get these new values. So now you have to check this new interval with the algorithm. Okay, so if you see, we have 0.6 and 0.9 which falls in this range. Okay, so what you do, output a 1 plus bit count number of zeros. So output a 1 and bit count number of zeros. So after this step your bit count has become 0. Okay, so you don't have to output any zeros, so you get only 1. Okay, next what you do, set bit count to 0 and subtract 0.5 from lower and upper bound and double lower and upper bound. So after subtracting 0.5 and doubling you get these two new values. Okay, so you have to subtract and double from both. Okay, so you get these new values. Now after getting new values, what you do, check with the algorithm. So if you see, these two values doesn't fall in any of these. Okay, so this value doesn't fall in any of those three. So what you do, you stop and take the next input letter. Okay, so you have a C here. Now after taking new input, you make the sub intervals and check the position of C in source. So position is 3, so you choose the third sub interval as your next current interval. Okay, so now check this, you have 0.7, 0.7. So if you see, 0.7 falls in between 0.5 and 1. Okay, see here, 0.5 and 1. So what you do, output 1 plus bit count zeros. What is your bit count currently? 0. Okay, so you just output a single 1. Okay, your bit count is 0. Okay, so you just output 1 1. So next what you do, set bit count to 0, bit count is already 0. Next subtract 0.5 and double the lower and upper bounds of current interval. So after subtracting 0.5 and doubling you get these values. Okay, so now you got new values. What you do, check the new values with the algorithm. Okay, so now if you see 0.4 and 0.5, you have 0.4 here but 0.57 which doesn't fall in this. You have 0.4 which is less than this. Now we have 0.4 which is greater than this and 0.5 which is less than this, so it falls in this one. So what you have to do, output nothing and increment bit count, subtract 0.25 from lower and upper bound and double the lower and upper bound. So what you do, you output nothing, then you increment the bit count. So your bit count here was 0, so now it becomes 1. Okay, and subtract 0.25 from lower and upper bound and double them. So after subtracting and doubling you get these values. Okay, now you got your new current interval. Again check this with the algorithm. So again if you see, these two values falls between these two numbers. Okay, so again what you do, you have to output nothing, that is you don't have to output anything. Then increment the bit count. Now bit count becomes 2 and subtract and double. So you have to increment the bit count. So your bit count is 1, now it becomes 2. Then subtract 0.25 and double, you get these values. Okay, so again what you have to do, you have to check these values with the algorithm. Okay, so now it falls in this. If you see, 0.4 and 0.6552 falls in this range. So you don't have to output anything and increment the bit count. So bit count was 1 previously, now it becomes 2. Okay, then subtract 0.25 from lower and upper bound and double. So after subtracting and doubling you get these two new values. Okay, so next what you do, your new current interval, check this with the algorithm. So if you see 0.3 and 0.8 doesn't fall in this because 0.8 is greater than 0.5, 0.3 is less than 0.5, and 0.8 is greater than 0.75. So it doesn't fall in any of this. So what you do, you stop and take the next input letter, that is hash. Okay, so after taking the input, make the subintervals of the current interval and choose the hash positions subinterval. So hash is at position 4 in the source, so you take the 4th subinterval as your new current interval. So now what you do, check this with the algorithm. Okay, so 0.7 and 0.8, if you see, this falls in this one. Okay, so 0.7 is greater than 0.5, less than 0.8 is less than 0.1. So what you have to do, output 1 plus bit count number of zeros. Your bit count is 2, so what you will do, 1 and 2 zeros. So you have a 1 and 2 zeros. Okay, so next what you have to do, set bit count to 0, subtract 0.5 and double the lower and upper bounds. So set bit count to 0. So after this step, bit count becomes 0. Okay, so next what you have to do, subtract 0.5 from lower and upper bound and double. So after subtracting and doubling from this, you get these values. Okay, so now check these values with the algorithm. So if you see, these two values falls in this one, so you don't have to output anything, increment, bit count, subtract and double. So you output nothing, you subtract 0.25 and double, and you get these two new values. Okay, so now you got the new values. Check this with the algorithm where it falls. So you have 0.3 and 0.74. So again, if you see, 0.3 is greater than 0.25 and 0.74 is less than 0.75. So it falls in this one. Again, you have to output nothing, increment the bit count. So now output, you don't have to output anything. Now bit count was 1, now it becomes 2, and you have to subtract 0.25 and double. So after subtracting and doubling, you get these values. Okay, last. So after subtracting and doubling, you get these new two values. Okay, this last one. Okay, so now what you have to do, you have got your new current interval. Check these two values with the algorithm. Okay, so you have 0.24, 0.98. So if you see, 0.24 is greater than 0, but 0.9 is greater than 0.5. See here, so it doesn't fall in this one. So you have 0.24 which is less than 0.5, so it doesn't fall in this, and we have 0.9 here which doesn't fall in this. So this interval doesn't fall in any of those three ranges. Okay, so now what you do, you have to stop. Okay, so now you have processed your entire input. Okay, you don't have any new input after this. So what you do, you have to stop here, and your this algorithm is complete. Okay, now after this algorithm, what you have, see here, after output bits you have finished arithmetic encoding. So you have to implement this. So now you have to, what you have to do, you have to increment the bit count and check if lower bound of current interval is less than 0.25. If it is true, this condition is true, you have to output 0 and bit count once, or else otherwise output 1 and bit count zeros. So check if lower bound of current interval is less than 0.25. So let's see. See this is the lower bound of current interval. So 0.24 is less than 0.25. So the condition is satisfied. So what do you do? Output 0 and bit count number of ones. So you have to output a 0. What is the bit count currently? 3. So you have to output 3 ones. Okay. So this is the last step. After processing all the input letters, you have to check this condition. If this is less than 0.25, if it is true, then you have to output 0 plus bit count number of ones. Okay. So you have this final output. Okay, output of the final step. Okay, so now what you have to do, you have to take this column and concatenate all the output bits. Okay, so what you get, 0 0 1 1 1 1 0 0 0 triple 1. Okay, so this is your final encoded string. 0 0 1 1 1 1 double 0 0 triple 1. Okay, so this is your final output. Okay, so these are your output bits. That's why the name arithmetic coding with output bits. And why binary? These are only binary numbers. Okay, so I hope it was clear to you. If you have any doubts, you can ask me in the comment section. Okay, so thank you for watching. Keep learning.